Good morning, mathematicians. Except now imagine I'm saying that in the sense of Charlie's Angels. Do you even know Charlie's Angels? Is that even relevant anymore? Probably not. He would say, "Good morning, angels." And then they'd say, "Good morning, Charlie." So then I say, "Good morning, mathematicians." And you say, "Good morning, K-theory." Anyways, let's draw more pictures of unitary representations. So then I say, "Good morning, mathematicians," and you say, "Good morning, K-theory." Or I should have planned listening to myself like that, so I could have. Charlie's Angels is goated? Okay. Well, Boris is old. That's what that means. Boris, are you an old man like me? If you know what Charlie's Angels is? Because Amina was already old when I was young, but then it went through a revival. But I don't think it's had a more recent revival, despite the fact that all any movies do anymore is just revive everything. Actually, I did see One Battle After Another the other day, so that's a new movie. Okie dokie. Let's talk about drawing unitary representations. So, well, first, actually, so we can look at, you can pretend to be a 12-year-old prodigy on the internet, right? Yeah, you could, that's a great thing about relative anonymity on the internet. I can't pretend to be a 12-year-old prodigy. I think, yeah, it's just, mind you, I could start a new channel and use some like AI face changer thing and pretend to be a 12-year-old prodigy. Oh my god, maybe that's a good idea. Maybe I should do that. Is this a good color? Yeah, that's a good color. What was I saying? Yeah, early days of internet. That was true. Well, it's still true. It's still true now. It's still true now. Just make an anonymous profile. So let's revisit the representations of GO1. Much in the same way for the supracuspidal case of GO2. I mean, basically everything's supracuspidal. And so we, again, have infinitely many infinitely tall tori. And it turns out that so they're all basically going to be some what might be called a ramified character times an unramified character, which is just the norm character to a plus bi, where remember b is only defined like modulo 2 pi I z, and this will only be unitary. Actually, yeah, this will only be unitary, or at least unitarizable, if a is equal to 0. And so we can draw a picture of all our unitary representations will be all these bands around these cylinders. So in the same way, we could draw pictures for the supracuspidals of GL2. We have all of our, again, we've just got all these infinite tori, or sort of infinitely many, infinitely long tubes, and each of those have a circular band of unitary representations around them. There's a slight edit we need to do there. Well, no, it's true. It does work out to be like that, but there's technically more explanation for why that's the case. But that's basically it. Coffee time. That's the kind of stuff you guys are here for. Now, what about the other kinds of representation? So last time, we talked about various different ways to try and draw the unramified representations. What did we have? Yeah, I guess one way of doing it was drawing like a product of these tori, and then actually we have to take some subspace of this product of tori. So we could still do that, I suppose. But now let's go remind ourselves about the unitary reps of GL2. And then who knows what we're going to do after this. Maybe go to Reddit, maybe go to archive, maybe, I don't know. Okay. So these characters are the only non-generic representations. Okay, let's see. These characters are the only non-generic representations. The tempered representations are discrete series where those characters are unitary. Wait, are these all the unitary reps? Hang on. Where's this Kudla article from? I don't know. I haven't the foggiest. Here's the info about it. I guess here's the DOI link. Can I drop this in chat? Nice. Yeah. It's a hard article to find, though. So if you're having trouble, shoot me an email, and I can just send it to you. Because I remember trying to look it up for someone before, and it was tough. Oh, the one I have is marked, because I think, actually, this is a PDF I got from my supervisor, and he'd marked it up. But whatever, it's very lightly marked up, so. Okay. Wait, square integrable unitary? No, I don't think so. Am I crazy? Ban this person for sharing links. Of course, yeah. Go check out the pirated ones just to be sure of what to avoid. Note that since local components of automorphic hospital representations will be unitary, it is important to identify the unitary representations. Right. General reductive group. This is very difficult. Solved by Tadich and Fogan. All such representations are twists of Steinberg. I'm not clear. Hey, Leo Lectures. I watched. I didn't watch it like end to end, but I did click through your video on the axiom of choice, and I did really like you used. How did you use it? You used a Venn diagram somewhere, or not a Venn diagram. Was it a Venn diagram? Somehow it was like things about the axiom choice that like seem contradictory but aren't. Good morning, Ken. And then there's some other, actually I don't remember what it was, but use some visual aid to talk about different aspects of choice and whether those were good or bad. And I liked your use of the diagram. Oh, sorry, Nicholas, I missed your question. I didn't see it at first. I do not know any pedagogy theory, but maybe I should. I applied for a postdoc in Melbourne, which they said they wanted someone with perverse sheaves experience. So I thought, well, okay, I'll put my hat in the ring. But they were more looking for categorical local language and Hodge theory, pedagogy theory type people. So I'm not a shoo-in, but maybe soon I'll learn more pedagogy theory. Mostly interested in comparison theorems for cohomology. How do I pronounce triangularizable? I think that's how I pronounce it. Sometimes when there's a word that I don't know how to pronounce, but I have like, say, 2 different pronunciations, I will just trade off the pronunciations until until someone corrects me. I don't know. My brain turned off for a minute there. Not a fan of how all the introductions to the subject focus on the algebraic framework and period rings without really diving into actual geometry. Yeah, what the hell? The remaining representations are these, where this is excluded by these theorem irreducible, in this case, the irreducible principal series representations. These are the only non-generic characters. Okay, but I'm still, I don't know, it's ridiculous that I don't know this. I should have this memorized. It's embarrassing, frankly, but tempered representations are the discrete series. Supercuspal representations and unitary twists of Steinberg and irreducible unitary principal series. Okay. So wait, that means we have I mean, certainly we have like the determinant characters for a purely imaginary exponent. Surely these are all unitary. Is the Steinberg representation unitary? It feels like it should be. But I don't know. Certainly these have to be. Yeah. Suring Hong. Oop. Surin. Oh, okay. Actually emailed him and he sent an updated PDF. Oh, nice. Very nice. Should we read through this next? No, I promised spectral sequences. I promised spectral sequences. This does seem cool and complicated. Any good references for sheaves and Cech cohomology? What is a good sequence? What is a good reference? I don't know. I think I have just a stash of random PDFs that I've learned from. I don't know if I personally have a particular reference. Discrete series is like stuff in L2, right? Yes. Yes. Tempered means the matrix coefficients are square integrable. Yes, that is true. You encountered these notes, but as far as you can tell, they also don't actually prove any of the comparison theorems. Seems like random PDFs are the thing. Yeah. I'm sure there's a book that's good. I'm sure if I thought about it more, I could conclude such a book. But okay, so we have the irreducible unitary principle series. So, the irreducible unitary principle series are inductions of unitary characters, so those should be purely imaginary. So if we think about our subspace, our space of representations is some subspace of the infinite product of these tubes, then we should basically I guess we should basically have like a torus. These correspond to like a torus of unitary representations of GL2. Wedhorn? Smooth manifolds via sheaves? Nice. Yeah, maybe, I wonder... Yeah, the thing is, it's like I guess it depends on what you want to do, though, because like I can think of a lot of textbooks that introduce sheaves and introduce Cech cohomology, but normally they just like define it and move on. I can't think of a book that has, for example, say like a bunch of worked examples of computing Cech cohomology of some cover or something. You know what I mean? Because there's like Wells' book, it's like differential complex geometry or something. And I think there's a section on Cech cohomology, but then, yeah, it's like very brief and he goes on to do other things. Learned a lot from Warner's book. I've never heard of it. Foundation of differential manifolds and Lie groups. Bit outdated, but perhaps the sheaf cohomology and Hodge theory are nice. Good to know. Yeah. Okay. So we've got a torus of unitary representations. Yeah. What are the other ones? The remaining unitary representations are the complementary series. So for any unitary character and alpha, and alpha from 0 to 1 in here. How do we picture those? How do we picture those guys? And so this is like new alpha plus AI, new minus alpha plus BI. So it's interesting. It's like there's another pair of tori, but it's like the product of this with the product of this, you know? So it's like this gives another torus, but somehow like this torus is somehow ones that are on the same level because the real parts are the same. And then this is some like diagonal product of the tori here. So I don't know what the point of all of me doing this was. I just thought it was kind of interesting, I guess. Yeah. In that case, don't think you should stress too much. Just learn the definition of Cech cohomology from any AG book, and probably the same for sheaf cohomology. Look up derived sections on an arbitrary site. Holy moly. I don't know what those are. Derived sections on an arbitrary site. Derived category, quasi-coherent modules. Quasi-coherent sheaves, we just say. Derived sections. The derived sections are the objects in the new category. Just usual sheaf cohomology, but on some general site. I see. Okay. Vector bundles are defined by Cech cocycles. That's a good basic starting point. Yeah, actually, what's this book? Rayburn Williams. Weird reference, but Rayburn Williams C-star algebras. Morita equivalence and continuous trace C-star algebras. Yeah. Weird reference, but go check out this book because I think they prove somewhere in here that vector bundles are classified by like second Cech cohomology. So derived functor of the global sections functor from the abelian category if she's on a site is a bit of a mouthful. Yeah. Yeah, this is an interesting book. One day I would like to read more of it in detail. But yeah, there's this little chapter on sheaf cohomology. Wow, there's Brouwer groups here? What the fuck? There's Brouwer groups. The Brouwer group of a point? What? What is the Brouwer group of a point? Yeah, see, this book is crazy. But anyways, Ken, even though you're looking at this for more general applications, whoa, why am I on page 256? What is going on? This is only part of the book or what? I think I have it somewhere here. Rayburn. Let me pull up the actual book. I've got a PDF. Rayburn Williams. First classes start tomorrow. What are you taking, Nicholas? Maybe you already mentioned previously, but I forgot if you did. Yeah, sheaves, cohomology, and bundles. Yeah, so Ken, even though you want a general education in Cech cohomology, I think it's still probably worth your time to look, like, probably understanding this application of Cech cocycles to vector bundles. This is probably, a good exercise. Algebraic geometry 1, algebraic topology 1. Nicholas, you're gonna slay these courses because you're talking to me about notes you've been reading about p-adic Hodge theory. You're gonna absolutely wreck those courses. Étale cohomology, elliptic curves, and attending some seminars. Wow, you got a lot on your plate. Maybe you won't slay those courses. That sounds like a heavy load, TBH. But well, I'm sure you'll crush anyways. Hello, Julie. It's been a while. Good morning. Yeah, let's see. Let us peruse this book. What do they got here? Right. Hoop-de-doodle. And look at that. I love that they call this a hoop-de-doodle. What is a hoop-de-doodle? I don't know, but I love it. The name AT1 is a bit misleading since it's the third course in algebraic topology. I see. The others are just topology 1 and 2. Okay. Well, it sounds like you got a crazy course load. TBH. I mean, very exciting because it seems like a lot of cool content, but yeah. Okay, here I think we're starting to talk about it, right? I mean, I guess this example, yeah, so this is a nice example. It's a bit of a deep dive on the first cohomology. You're supposed to do homework, but a K-theory live stream is too enticing. Well, the ideal way to live one's life is to do your homework with K-theory live stream and K-theory long form content in the background. That's the ideal way to live your life. Steinbeck reference? Is that, is Hoop-de-Doodle a Steinbeck reference? Really? Hi everyone, is real analysis 2 meant to feel like slamming your head against the concrete? Yes, Gmozzie, yes. Yeah. The first analysis course which I took which was basically analysis 1 and analysis 2 merged into one course. That it turned me from a boy to a man. And that's exactly what slamming your head against concrete feels like. But you miss out on the cool math on screen. Well, maybe that's true. Okay, we're doing short exact to long exact here. Where is it? Show me Rayburn Williams. Show me the sheaf thing I'm looking for. The shrinking lemma. Honey, I shrunk my sheaves. Oh, it's a word that he coined? Okay, cool. Ah, thanks for mentioning. See, I learn new things in my live streams every day. Okay, we must be getting close. Is it here? Maybe it's in this example here. Well, here he's talking about solving logarithms of f via cohomology theory. Cohomology provides a home for this. Yeah. Co-cycle representing a generator. Sure. Winding number. Sure. Well, this book really has a lot. This book really spends a lot of times on sheaves and sheaves cohomology. So, Ken, if you're still around, I hope me scrolling through this has sold you on taking a look at this book. Uniform convergence is just a cursed thing to long for. G-Mazi, I'll forgive you because you know not what you say. It is the greatest thing to. I mean, when you first learn calculus, at least in my calculus, and calculus that they do here, and I think this is typical across North America, we tell you that you can just swap. We tell you that you can just swap these things. We don't tell you that in general, but I mean, I've seen problems on problem sets where basically the thing you have to do is swap these. And like, yes, the ones that they tell you, the examples they tell you to do that, these are, uniformly convergent series of functions, basically. Like e to the x, right? And it's Taylor series. But would you say that it's insane to long for wanting to swap an integral and a sum? I think this is one of the most natural things to do in the world. I mean, swapping limits in general is something that you want to do, or to swap a derivative and a sum. Of course. You're just bad at showing where it exists. Okay, well that's different. That's different. But don't come attacking analysts. Don't come attacking analysis on this channel because of it. Because I'm gonna clap back. You feel like these live streams will, but put you into an infinite rabbit hole? Yes. That is their plan. This whole channel is actually a psyop from some unknown other government. It's not the one you think it is. And I'm just trying to distract everyone by putting you into an infinite rabbit hole. You started learning group cohomology again. Hell yeah. Thanks to the Gawa cohomology. Yeah. Hell yeah. Group cohomology, sheaf cohomology. That's where it's at. They're the same picture, yeah. Abelian G module, same as a sheaf of abelian groups on the de-looping space. You can look at the syllabus. Nice. You want to swap limits with colimits? Well, you can. Right? Those are the ones that commute. You can't commute to limits, and you can't commute to colimits. But limits and colimits swap, do they not? right? The opposite swap, I'm pretty sure. Apology accepted, Gmazi. I mean, I'm not even an analyst, but you know. So I feel like it's kind of my job to make fun of them, but only in certain ways. Only in certain ways. Certain things are just straight up slanderous. Yep, time to go to NLab. Time to go to NLab. Yeah, math is just a whole bunch of infinite rabbit holes. Swapping is just Fubini for Radon-Nikodym measures. Perhaps that is true. Perhaps that is true. Wait. Because you're viewing the sum as some sort of counting, as an integral over some sort of counting measure? Is that the idea? Not sure specific reference. Maybe Feibel mentions it. There is just a morphism from lim to colim of thing into colim lim, not an isomorphism. Oh. Weird. Why did I remember that they could be swapped? Misremembering, I guess. Special case of that is the analysis theorem of inf sup less than sup of inf. Oh. Is the... Huh. That's nifty. That's a nifty little thing. Now, this is strange. We're already in the appendix. Is the proof here in the appendix? Oh, fiber bundles. It must be in here then. I see. That was the appendix to the subsection. Let us... Okay, let's keep scrolling through this. And then we'll end the stream. We're going to end the stream soon. But I'm determined to find this before we're done. Oh, wait. Oh, maybe it was principal bundles. Maybe it was principal bundles. Yes. Here's the theorem I was thinking of. No, I thought there was one. I thought there was another one, but okay. Oh, but principal bundles are vector bundles. Or vector bundles are principal bundles. So this is, yeah. Suppose G is an abelian topological group of homeomorphisms on F, and we have another topological space Z. Then the map which sends a fiber bundle to the class of its transition functions. He doesn't say over which base space. Presumably F is the fiber. Yeah, it's got to be the fiber. You're back, Leo Lectures. I didn't even know you left. Analysis theorem being a special case of category theorem was the last thing you would ever expect. Yeah. Sup and lim stuff is hardly analysis, more like lattice theory. Yeah, I mean, well, I guess, but like everything you define in analysis 1 is like sups and infs, right? Anyways, then the claim is that the map which sends a fiber bundle to the class of its transition functions induces a bijection of the set of isomorphism classes of vector bundles. Oh, he does specify the base face and fiber of Z with fiber F and structure group G onto the sheaf cohomology group H1ZG. Yeah. So this is the theorem. Proposition 4.53 of Rayburn-Williams. Wonderful stuff. You love to see it. Hello, McGreevy. You felt like 2 seconds in, you had a work schedule thing that blocked YouTube. Oh, too bad. Did you see then? Did you hear then me commenting about that I liked your diagrammatic explanation in your axiom of choice video? Because I did. I liked that you used a Venn diagram or something like that. I thought that was a nice way to picture different things, different interpretations of different consequences of choice. This bundled perspective also explains well why first cohomology is represented by KG1. That I don't quite get. Everything is set theory unless you're an ETCS or UF guy. I'm kind of a UF guy. Kind of. I like it from a distance. Well, I'm glad you came back to hear it now, Leo Lectures. Arad is a hot guy. Can confirm. Just go look at his blog. You're a traveler of both time and space to be where you have been. Well, McGreevy, Dr. McGreevy, in fact, everyone is a traveler of both time and space, I would say. New foundations? What is that? Is that what, John Gabriel? Or you have ugly guy. Well, anywho. Oh, look, and he even mentions turn classes. Wow. I really got to go back and reread this book. But there's only so many hours in the day. That's the rub. It sounds good, but doesn't mean much. It's a Led Zeppelin line. I mean, yeah. Everyone travels through space-time at sea. Wait, do we travel at sea? Wait, what? Is that true? What if we had a stream where you asked me about the basics of Lie theory sometime? That would be crazy. I'm down, Leo Lectures. We could even have like a Zoom stream, like a live thing where we have a live Zoom chat. I would be down for that. Maybe email me. So this Wednesday, I'm supposed to give a talk in a seminar about basics of Lie theory. And so I'm probably just going to separately record a version of that talk. And then later upload it. But that might not be for like a couple of weeks or something. Because I think this Friday, I want to make another video about extensions of groups. And then just because I think it might be popular and I'm a greedy little subscriber goblin, I might make another video reading Vixra papers. Can someone explain Yoneda to you? Actually, the best yes, someone can, and that someone's name is sheafification of G. Who hasn't posted in a while, and that makes me sad. Why am I getting ads for gaming addiction? What is the internet trying to tell me? I don't game at all. Well, I play chess sometimes. Hello, regulars shorts. Hello, Gemezik. I just sent you the link, Dr. McGreevy. You just have to stare at Unita longer. Yeah. Oh, Paul Maurice. Good to see you. It's been a while. Glad to have you back. I mean, you're here at the end of stream. I'm trying to leave. I'm trying to get out of here. Can I explain what the greens function? Is that what you're asking? I mean, chat's really popping off. You watch that video? Oh. Well, then, if you already watched that video, I don't know, go read Tom Leinster's notes on basic category theory on Archive. But maybe tomorrow we can talk about the UNA dilemma in my live stream. Okay, if I remember, I will talk about the UNA dilemma in more detail in tomorrow's live stream. Yes, the G++. You've been getting ads for the perfect supplement to help your ovulation, and you didn't even know you could do that. Well, yeah, sometimes the internet can teach you interesting things about yourself. Would Yoneda have anything to do with quadratic imaginary fields? I can't think of any obvious way in which they would connect in any meaningful way, but no. But maybe there's something to say. I mean, quadratic imaginary field is an embedding of fields, and you could look at that in the category of fields, and then yeah, I don't know. I don't know if it's worth plugging it into Yoneda. How many problems should one do per chapter for a textbook, or it doesn't matter? Doesn't matter, yeah, until you feel comfortable. That's basically the answer. Yeah. Yeah, exactly. And it's possible to say without more context. Can the Green's function be considered a sort of mass or current? I think so. I don't remember. It's been a while since I looked at the Green's function. And the moduli space of a sort of volume, if you get a mass and a volume, you got a density. I don't know what this has to do with moduli spaces, but yeah, something about arithmetic geometry. I mentioned Green's functions in my master's thesis, actually. I didn't understand what was going on. Wow, chat is popping off. It must be a Sunday. It must be a Sunday. Oh, Yoneda understand a Hopf algebra. That would be a good exercise. Well, that's all right, Dr. McGreevy. It's all part of the learning process. It's all part of the learning process. We should definitely do some arithmetic geometry of elliptic curves. That could also be a good idea. There's a lot of good ideas for this channel. Okay, but the plan is, if I don't forget, tomorrow we'll do Yoneda. You have it on your list to make a video about elliptic everything, since you do cryptography. And you know some elliptic curve geometry as well. Yeah, nice. Well, on that note, I think I'm going to peace out and go do some work. So thank you all for joining me. And yeah, QED.